Hi everyone, welcome to Mathnospedia. Here we are going to start lecture 9 of our course Basic to Advanced Level Real Analysis. In this lecture, our topic of discussion is test of convergence of series of real numbers. Our aim in this course is to solve PYQs after discussing concept of each topics. The full course divided into 4 parts. पार्ट 1 पे फंक्शन, रियल नंबर सिस्टम, सीक्वेंस सीरीज, कॉन्टिन्यूटी एंड डिफरेंशिएबिलिटी कवर होगा. पार्ट 2 पे रीमान इंटीग्रल एंड टोपोलॉजी ऑफ रियल नंबर कवर्स होगा. पार्ट 3 पे काउंटेबल सेट एंड अनकाउंटेबल सेट कवर होगा. एंड पार्ट 4 में सीक्वेंस सीरीज ऑफ फंक्शन एंड फंक्शन ऑफ बाउंडेड वेरिएशन कवर होगा. आप लोगों को ट्यूसडे, थर्सडे एंड सैटरडे को 7 PM पे लेक्चर मिल जाएगा. जैम एंड नेट के लिए पार्ट 1 एंड पार्ट 2 एंड ओनली फॉर नेट पार्ट 3 एंड पार्ट 4. अभी हम लोग पार्ट 1 पे है, जहाँ पे फंक्शन, रियल नंबर सिस्टम एंड सीक्वेंस कवर कर चुके हैं. अभी हम लोग सीरीज पे है. द लास्ट लेक्चर हम लोगों ने सीरीज स्टार्ट किया था, जहाँ पे हम लोग देखे थे सीरीज क्या होता है एंड इट्स कॉन्वर्जेंस क्या होता है, नेसेसरी कंडीशन ऑफ कॉन्वर्जेंस क्या होता है, व्हाट इज जीपी सीरीज एंड इट्स एग्जाम्पल, and then what is P series and its example, and what is Cauchy condensation test. Today in this lecture 9 our topics जो कवर होगा वो है रेशियो टेस्ट क्या है विथ एग्जाम्पल, रूट टेस्ट क्या होता है, डिरिचलेट टेस्ट क्या होता है, लीबनिज टेस्ट क्या होता है एंड एबेल टेस्ट क्या होता है. विथ एग्जाम्पल वी विल सी ऑल दिस टेस्ट ऑफ सीरीज. सो बुक आप लोग फॉलो कर सकते हो एसके मापा, मालिक अरोड़ा एंड बार्डले एंड सोबर्ट का. दोस्तों इस लेक्चर में जो जो कुछ कवर होगा आप डाउनलोड कर सकते हो www.mathnospedia.in से. अगर कोई भी क्वेरी और डाउट्स है तो आप पूछ सकते हो mail@mathnospedia.in पे ईमेल भेज के. मैं कोशिश करूँगा आप लोगों को डाउट क्लियर करने के लिए. सो लेट्स स्टार्ट टुडेस लेक्चर. So we have already seen in the last lecture that the test of series are two types: absolute convergent test and non-absolute convergent test. In absolute convergent tests, the series term must be greater than or equal to 0, and for non-absolute convergent test the series term can be greater than 0 or as well as less than 0. There is no restriction. Okay, so now there are few absolute convergent tests which are Cauchy condensation test, ratio test, root test, and there are few non-absolute convergent tests. There are Dirichlet test and Abel test. हम लोग ऑलरेडी Cauchy condensation test देख चुके हैं. आज हम लोग स्टार्ट करेंगे रेशियो टेस्ट. So what is ratio test? Ratio test क्या है? Suppose A and B any sequence where your given series is an with an greater than 0, then if you consider the limit lim n tends to infinity an plus 1 by an, then the series an will convergent if L less than 1 and divergent if L greater than 1. ठीक है. The ratio test will inconclusive, मतलब कोई भी कंक्लूड नहीं कर सकते कॉन्वर्जेंट और डाइवर्जेंट होगा कि नहीं अगर जो लिमिट है यहाँ पे 1 आ जाता है. ओके, देन वी विल नॉट कंसिडर रेशियो टेस्ट. नाउ लेट अस सी एन एग्जांपल. सपोज गिवन ए सीरीज n to the power p by e to the power n. Let us check by ratio test. So consider an is equal to n to the power p e to the power n. Then a n plus 1 क्या होगा? n plus 1 to the power p by e to the power n. Okay. Then if you find the limit L n tends to infinity a n plus 1 by a n, then you will get n plus 1 to the power p by e to the power n plus 1 into e to the power n by n to the power p. If you simplify this, you will get lim n tends to infinity n to the power p को यहाँ पे ले आओ, so n plus 1 to the power p by n to the power p and e to the power n by e to the power n plus 1. So ये हो जाएगा लिमिट n टेंस टू इन्फिनिटी 1 प्लस 1 बाई n को अगर अंदर ले जाओगे तो ये हो जाएगा टू द पावर p एंड इसको कट करके आ जाएगा 1 बाई e. So this is actually the limit will be 1 by e, okay, which is less than 1. So by ratio test we can conclude that the given series is convergent. Okay, now what is root test? The root test says that if a and be a sequence with positive numbers and L be the limit n tends to infinity n to the power 1 by n, because of the power 1 by n, this name is root test. Okay, so then if L less than 1, then the given series convergent, and if L greater than 1, then the given series divergent. Okay, here also note that this test also inconclusive if L is equal to 1. L is equal to 1 के लिए आप कुछ भी नहीं कह सकते by root test. Now let us see an example. The given series is 1 by log n to the power n. So here consider a n to the power log n to the power n. So a n to the power 1 by n क्या होगा? 1 by log n. Okay, this and 1 by log n tends to infinity क्या होगा? 0 हो जाएगा, which is again less than 1. So by ratio test, by root test, the series यहाँ पे log n होगा, log n to the power n is convergent. Okay, now what is Dirichlet test? The Dirichlet test says that if an and bn be any two series given, and the first condition is the sequence of nth partial sum Sn of the series an is bounded. That means one of the series the sum of one of the series sequence Sn must be bounded. So that means there exists Sn less or equal to m. Sn less or equal to m होगा for some m n के. Sn क्या होता है? Sn is equal to nth partial sum a1 plus a2 plus dot 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 plus an. Okay, and the second condition is the bn monotonically decreasing and the limit of bn must be 0. That means the nth term of the series bn must be monotonically decreasing sequence. Okay, and limit must be 0. Then we can say that the product sum a and bn must be convergent. Okay, so if for any two series, one series has nth partial sum bounded and other sequence of the series is monotonically decreasing and 0 limit, then the product sum is convergent. So let us see an example. With Dirichlet test, we will show that this series is convergent. Okay, now consider an is equal to minus 1 to the power n and bn is equal to 1 by n. Okay, then if you consider the sum Sn is equal to a1 plus a2 plus dot 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 n, then you will get minus 1 plus 1 -1 like this, and डिपेंडिंग अपॉन ऑड और इवन यहाँ पे -1 और 1 आएगा. सो ऑब्जर्व दैट वेदर it is -1 or 1, the sum is always finite here. Okay, sum is finite. So that's why we can say that the nth partial sum Sn is bounded. So we have a series whose nth partial sum is bounded, and Bn is equal to 1 by n, and we know that this series is decreasing, this sequence is decreasing, we already know, and n tends to infinity, 1 by n goes to 0, so it is monotonically decreasing and converges to 0. So by Dirichlet test we can say that the product Bn is equal to -1 to the power n into 1 by n is convergent. Hence the given series is convergent. Now an important corollary says that Dirichlet test का एक important corollary है Leibniz test. Okay, or alternating series test. Observe that in the Dirichlet test A and Bn convergent, okay, where An has nth partial sum bounded and Bn is monotonically decreasing. Now if we consider An is equal to -1 to the power n in particular, and Bn is some monotonically decreasing series, okay, then we can say that by Dirichlet test this series is convergent. Okay, and this is known as Leibniz test or alternating series test. Let us see its theorem. If n be any series with n monotonically decreasing and n tends to 0, specifically for the Dirichlet test, here Bn is equal to n, and here n is equal to -1 to the power n. So that's why we can say the series -1 to the power n An is convergent. Okay, now a very important test is Abel test. Abel test के जरिए भी हम लोग प्रोडक्ट सीरीज को कन्वर्जेंट होगा कि नहीं हम बोल सकते हैं. Consider two series An and Bn be two series, and if the first condition is the one of the series must be convergent. So suppose An series is convergent, okay, and the second condition is Bn is monotonically decreasing and bounded. So observe that in the case of Dirichlet test, n का partial sum sequence was bounded. Here it is थोड़ा आगे जाके बोल रहा है, एक्स्ट्रा बोल रहा है कि n का पार्शियल सम बाउंडेड नहीं, पार्शियल सम एक्चुअली पे कन्वर्जेंट, तो ही सीरीज कन्वर्जेंट होता है. सो यहाँ पे बोल सकते हो कि यहाँ पे n का पार्शियल सम Sn is convergent. n series convergent mean that nth partial sum convergent होगा. ओके, Dirichlet टेस्ट पे क्या हुआ था? Dirichlet टेस्ट पे एक्चुअली Bn टेंड्स टू 0 हुआ था, लेकिन यहाँ पे ऐसा कुछ नहीं होना पड़ेगा. यहाँ पे जस्ट Bn मोनोटोनिकली डिक्रीजिंग एंड बाउंडेड होने से ही काम हो जाएगा. सो here if An is convergent, C is convergent, and Bn sequence is monotonically decreasing and bounded, then by Abel test we can say that the product An Bn is convergent. Okay, this is very important. So note that Dirichlet test is the special case of Abel test. What we have already discussed. Abel test पे बोल रहा है कि An is convergent, and that means Sn ka partial sum is convergent. Okay, and but in the case of Dirichlet test it is the special case, because here in the case of Dirichlet test we don't need the condition convergent, we just need the condition Sn is bounded. We can obviously say that the Dirichlet test is the special case of Abel test. So let us see an example by Abel test. We will prove that this series 1 by n log n to the power n is convergent. So consider n is equal to 1 by log n to the power n and bn is equal to 1 by n. Then we know that this series n is convergent. Why it is convergent? Because by root test we have already seen n to the power 1 by n is equal to 1 by log n is equal to 1 by log n, which goes to 0 less than 1. Hence by root test we can say the series n is convergent. Okay, now the second sequence is that bn is monotonically decreasing and also bounded. Why it is bounded? Because its lower limit is 0 and upper limit is 1. By 0 and 1 इसका bound है, so monotonically decreasing भी है and bounded भी है. So by Abel test we can say that the product nbn is equal to 1 by n into log n to the power n is convergent. That's it. This is so easy if you understand the topics. So we have to stop now. This is the end of the lecture. We have discussed all the series tests here. There are no remaining such important series tests. Okay. In the next lecture, we will discuss the PYQs from net and jam regarding series. Okay. So that will be a very important lecture. So till then, goodbye.